Welcome back. So, we will continue the introductory part of this robotics course. So, in the last class I briefly mentioned about the various applications of robots and then how people are actually using robotics in various fields. And we saw that because of the varied applications and or all people from different walks of life, we have a difficulty in defining the robots. So, for some time it may be a hobby for many people, sometimes it may be an engineering discipline or it may of a technology used in the industry. So, one definition is not really going to suit for the robotics, and that is why we saw that the earliest definition or the definition existing or it was existing for quite some time. It was like a robot is a software controlled mechanical device that uses sensors to guide one or more end effectors through programmed motions in a workspace in order to manipulate physical objects. So, that is more suitable for an industrial robot, and then the current generation robots do not really fall into this definition. That is why we got a new way of defining robot as the intelligent connection of perception to action. So, this is what actually we saw in the last class. So, when I say intelligent connection of perception to action, it basically says that I have a perception of doing something which is not possible for me in the normal situation or using the current level of technology or the current level of products available. I am not able to do, but I have a perception of doing that. And if I can actually make it happen through some intelligent connection, then we call it as robotics. So, to give an example, assume that I have a perception or I have a perception of getting my lunch delivered to my office simply by pressing a button or activating something. So, I do not want to go home, I do not want to take my car and then go home for lunch and then come back. Instead, I would like to have my car just when I press a button, I want my car to go to my home, collect my lunch and then bring it to my office somehow. If it is I mean that is my perception. So, I have a perception of having my lunch delivered to my office. So, this is my perception. Now, the question is that whether I can do it through an intelligent connection. So, one way of I can have an assistant or somebody to do this, or I can actually have a driver to drive my car and then come back with lunch, or I can have a delivering agency doing this. So, these are all possible way to get my lunch without me going out of my office. So, that is my perception. So, my perception is I do not want to go out of my office, I want my car to get my lunch. And as I mentioned, there are many ways to do this. But if you look at, there are no intelligent connection in any of these, because my perception of getting lunch and then delivering the lunch as the action. The action is basically getting the lunch without me going out of my office. Now, if I can have a intelligent connection, for example, if I actually convert my car into a fully autonomous car and then program my car to go to my home and collect my lunch and then bring it back to my office, then there is an intelligent connection. I am actually connecting my perception to action through an intelligent means. So, that kind of an intelligent connection if you can see in any of the systems or products, then we call it as part of robotics, or we call that as the robotics technology. So, this is the way we can define robotics, because any other definition will not fit for all the type of robots existing in the field. And that is where we say that if you can have an intelligent connection of perception to action, then we call it as robotics. And to what extent you can call it as robotics, that it depends on what extent is your intelligent connection, how intelligent your system, or how intelligently you are connecting this perception to action through some means, through actuators, sensors, control or whatever it is. And if that is having that intelligent connection, then we call it as robotics. So, this is the way how robotics is defined nowadays. Of course, you can always question this definition, because again it is not really defined what you mean actually intelligent connection, how intelligent it has to be. can be simply a remote control, or it can be a fully autonomous. So, all those things are there, but we do not get into that those details, but we will say in general we can say if there is a perception and there is an action, and if these two are connected through intelligent means, and if we are achieving this perception to action through an intelligent means, then we can call it as robotics. So, that is the way how we can define robotics now. So, let us briefly look into the history of robotics, how the robotics technology evolved over a period of time, and what is the current status. So, if you go back to the 14th or 15th century, it was Da Vinci who actually brought something into the field, or something called robot, Leonardo's robots, which were actually make something like a armored, it was like an armored knight which move like a human, so designed to make the knight move as if there was a real person inside. So, that was the mechanical device that looks like an armored man, proposed by Da Vinci in 1495. And it was only in 1920 this Czechoslovakian playwright Karel Čapek introduced the word robot in his play Rossum's Universal Robots, and the word comes from the tedious labor. So, robot actually means tedious labor, and this play actually introduced the word robots, and we continue to use this one for many years now. And it was Asimov, most of you must have heard about Asimov, he is a writer, and he publishes the book Runaround, in which he defines 3 laws of robotics. And then actually we did not have any robot at that point of time, and even this play also he actually introduced the word robots. And 1942 these 3 laws of robotics were this were published. We will see what are these 3 laws, more of an historical importance. And then a lot of things happened. In 1951 a teleoperated articulated arm for the Atomic Energy Commission was used, because in nuclear installations handling of nuclear fuel is an issue. So, they need to have something called a teleoperation that can operate the device from a remote location. So, in 1951 in France they brought this kind of device, and that was regarded as one of the major milestone in force feedback technology. And again in 1954 the first programmable robots was introduced, Universal Automation, planting the seed for the name of his future company. So, it is a Universal Automation, Unimation was the robotics company. So, they introduced this programmable robots for industrial applications. And of course, in 1962 General Motors purchased the first industrial robot from Unimation, that is the Universal Automation company Unimation, and it installed it on a production line. The manipulator is the first of many Unimats to be deployed. So, it was somewhere in 1962 we had this first robot coming to the industry for practical application. It was somewhere in the same time in 1965 this homogeneous transformation applied to robot kinematics was published by Denavit and Hartenberg, and that actually is one of the major milestone in the kinematic analysis of robots. So, they proposed a methodology to analyze the kinematics of robots and introduce the homogeneous transformation methods. And then after that there were a lot of development taking place, because a lot of industries came up with robots like Puma, Stanford arm, then we have this Puma robots, Puma, and then Brooks Automation started introducing a robot called SCARA or SCARA configuration, and then Fanuc also started working on industrial robots. And it was somewhere in 1994. So, parallelly with the industrial robot, lot of people started thinking of various kinds of robots. So, the industrial robot was a fixed base one, and people started thinking of mobile robots, walking robots, etc. So, a 6-legged walking robot was introduced somewhere in 1994, and it was somewhere 1995 Intuitive Surgicals came up with their medical robots, and then NASA's Pathfinder missions started in 1997, and the Asimov or the humanoid robots was introduced in 2000, and 2001 there were this space robots. The space station robot was introduced in by Canada, known as Canadarm was introduced in 2001, and after that after 2000 also there are a lot of things happened. 2001 to 2020 we had lot of applications being developed by various industries and academic institutes. Okay, underwater robots were introduced, and then space robots, robots for elderly care, healthcare robotics. So, a lot of development took place. So, this was just to tell you that the robot history is not very old. It was somewhere in 1960 the first robot came. So, we are only 60 years old the field, but it has actually spread very far and far wide applications, and still a lot of research and development is taking place. Though a lot of interest and lot of people are working, still we have a long way to go, because the technologies and the systems available are still far less adequate than what actually we expect the robots to do. So, this was just to tell you that research and development is still going on, and a lot of work is to be done in order to make good robots, autonomous robots to serve the humanity. Okay, so I mentioned about this laws of robotics. So, as I told you, it was actually proposed by Asimov in his book Handbook of Robotics. Actually, he proposed these 3 laws. It is of more of an historical importance, but still as robotics engineers you should know somebody proposed these laws, and then they actually still have some kind of relevance in the in terms of human behaviors and humanity. So, the first one was basically a robot may not injure a human being or through inaction allow a human being to come to harm. So, no robot should be allowed to bring harm to a human. So, that was the first law. And the second one, the robot must obey the orders given it to by human beings except where such orders would conflict with the first law. So, whenever instruction is given to the robot should follow the human, or whoever is giving the instruction, the robot should follow, provided it is not against the, or it is not in conflict with the first law. That means you cannot ask a robot to injure a human being, then the robot should not follow that instruction. And then the third one is a robot must protect its own existence as long as such protection does not conflict with the first or second law. So, that is the third law. A robot must protect its own existence as long as such protection does not conflict with the first or second law. So, the robot should not destroy itself, or it should not take an instruction to destroy itself from someone, because that as per the third law it should always try to protect its own existence as long as it is not in conflict with the first or second law. So, this is the these are the 3 laws proposed by Asimov long back, but someone thought that these are not sufficient to protect the humanity from robots. So, it does not talk about humanity as a whole, and it is possible that a robot may be in control of a nuclear station or a very lethal weapon, and it can actually wipe out the humanity by an action or an inaction. That is why a 0th law was added later to make sure that the robots are the humanity is protected, or the humankind is protected from the acts or non-acts of robots. And the 0th law says that a robot may not injure humanity or through inaction allow humanity to come to harm. So, as a humanity, total human species should not come to harm through action or inaction of a robot. So, this was added as a third or a 0th law of robotics. So, as I told you, it is of more of historical importance. Still people I mean nobody will really checks whether the robot follows the laws 1, 2, 3 etc. There is no checking or standardization based on the laws, but as a moral principle or an ethical principle of design of products, we still ensure that the robots do not injure human, or robots do not harm the humanity. But many times it is not really feasible to follow all these laws, because technically speaking a medical robot or a surgical robot is used to cut open the human body or to do some surgical procedures in the human body, and technically speaking it is actually injuring the human, though it is controlled by a doctor. So, we cannot really say that the robot should not injure a human being in that sense, and that is why it is not possible always to ensure that all these the laws are followed, but we look at the spirit of the law and then see whether we are able to follow the spirit of this law and make sure that the human as an individual or humanity as a whole is not getting affected by the robot's action or inaction. So, that is about the laws of robotics. So, now let us look at the field, how the evolution actually happened in this pictorial representation. So, this is from a paper published in IEEE magazine. So, you can see that if you look at the growth, the evolution of robotic research, as I told you, it was somewhere in 1960s the industrial robots actually started coming into the market. It was so this was the period where actually the industrial robot had very good growth, and lot of robots came into the market, and lot of industry started using industrial robots. And it was somewhere in the same time, somewhere in 1970s, because of the success of the industrial robots to do many tasks in the industries, people started using or thinking about, can we use these for other applications also, not only in industry, and that is where the mobile robots, walking robots and humanoid robots were actually started getting attention, and many research centers and few industries started working on these robots. But there was not much of growth in that area, because most of the focus was on industrial robots. Most of the people were looking at the application of industrial robots, especially in the automobile industry and all. And it was somewhere in 90s and beyond, everyone realized that the industrial robotics technology is almost maturing, and there is nothing much you can do, because whatever we are doing, we can do is being done in the industries, because a lot of robots are being used. And there was improvement taking place in terms of the load carrying capacity, control and sensors and things like that, but there was not much of research or development taking place in terms of new products coming to the market, and therefore it was actually saturating, and people realized that the technology being developed for robotics, because a lot of people were doing research in terms of development of controllers, development of sensors, actuators, etc. And the impact of those developments in the industrial robot was not very significant, and that is where people started thinking, okay, can we do this, can we take this technology to other fields, or can we take the technology to application areas where we have where we can bring the robot more closer to the human. And then we started this area of field and service robots that included underwater robots, personal robots, then construction robots called as field robots, then security robots, medical robots, assistive robots, etc., domestic robots, surveillance, etc. So, the current focus of robotics research is to see how we can use this robotics technology for an application, the field or service application. Can we take this technology, use this technology or integrate this technology and the systems in order to get a new application. That is where the focus of current robotics research is more on the field and service robotics. If you can actually find an application and develop a system, a robotic system to suit that application, then you are actually contributing to the field of robotics. Otherwise, if you develop the technologies and then we are not able to use them effectively, then we are not able to take forward the robotics field, and that is why lot of research and development is taking place in the field of field and service robots, that includes robotic application in any field. So, you can name any field, and if you can find a robotic solution, then we are actually contributing to the growth of robotics. So, if you are interested in robotics, once you take this basic course on robotics, which actually introduces you to the very basic fundamentals, your focus should be on to see how can we take it forward, or how can you use this knowledge to develop robots for field and service applications. Okay, I hope you got the fundamental principle of the robotics, how the robotics field is growing, and what evolution is taking place in this field. Okay, just to tell you a few things about robotics. There are many myths about robotics, or people, because as I told you, there are a lot of hype created in the media about robotics. So, there are a lot of myths about robotics also. So, this was actually from IEEE Spectrum 2014. So, one of the major myths is that the robots are intended to eliminate jobs. So, in the first look, if you see, then you will see that okay, there were a lot of industries where actually robots replace the human operators. Maybe true if you look at only that aspect, but then it actually created a lot of jobs in many other fields. And therefore, it did not really eliminate jobs, but actually it actually moved the jobs from the shop floor to some other place. So, that is what actually happened. So, therefore, the robots are intended to eliminate job is a myth. In fact, it is actually to enhance the capability of human, and to enhance the productivity, and to ensure that the quality of production and quality of output increases with the use of robotics technology. So, elimination of job is not at all true, and it is a myth. And one of the important facts about robotics is that manufacturing and logistics must adopt robots to survive. So, if the industry has to survive, it has to adopt the robotics technology, because automation plays a major role, and robotics is one of the key elements in industrial automation, which actually allows the industries to enhance their productivity, improve the quality of production, and that will actually help them to survive in the market. And another fact is that the autonomous robots are still too slow. So, this I told you, we have a long way to go to get a fully autonomous robots. So, though there are a lot of research going on both in terms of technology as well as in terms of products, we are still far away from having a fully autonomous robot which can function the way we want, because most of the autonomous robots are too slow nowadays, mainly because of our limitations in sensing, perception and control. And robots are too expensive also is a myth, because the cost of robot is actually coming down, and looking at the capabilities of the robot, the capability of robot increases and the cost is also coming down, and therefore, the overall reduction cost is very high, and therefore, the notion that the robots are too expensive is actually a myth. And this still remains as a fact. The robots are difficult to use, and this is where actually we need to do a lot of work to make the robots easy to use. Still we do not, I mean, our robots are still not that friendly with the human. We still do not have full trust on the robots. So, we keep the industrial robots away from the human. We try to have fencing and other things. And the current trend of developing cobots, some of you must have heard about this. Cobot is basically a collaborative robot. So, the industrial robots are slowly getting replaced with cobots, where the robots can actually work with human, and the robots are made in such a way that it do not really hurt the human or cause injury to the human. So, that is basically the cobots. Though this kind of development is taking place, there are again lot of challenges, and we are having difficulty in using robots for practical application. So, these are the facts and myths about robotics and robotic technology. So, we need to understand that like any other technology, robotics has also got lot of advantages and a lot of limitations, and the focus is basically to see how can we overcome the shortcomings of robotics technology as well as the robots, and then make it more and more user friendly, more and more human friendly, and that will lead to the acceptance of robotics for many more applications. So, any robotics engineers focus should be to see how can we develop better applications and how can we make it come more closer to the human being and make it more useful to the humankind. Okay. Yeah. Now, let us look at the enabling technologies for robotics. So, we mentioned that robotics is an interdisciplinary field, and then you need to have an understanding of interdisciplinary subjects or multidisciplinary subjects you need to understand in order to learn robotics as well as to do research or development in robotics field. So, if you look at the I mean robotics is also part of automation. So, if you look at the pentagon of automation, so this is known as the pentagon of automation, where we see that these 5 elements actually contribute to the automation field. So, the most important part is the actuators. So, any automation we need to have a motive power to move things, and that actually comes from the actuators. So, the actuators be electrical actuator or mechanical or hydraulic, whatever it is. So, these actuators provide the necessary power for the system, and then we need to have sensors in order to get data, and then based on this data we can get the actuators provide the necessary power. So, sensors may become an important element in the automation pentagon. And the other one is a processor. A processor is the one which actually process data and then take decisions based on the intended motions as well as the current situation. So, it actually collects the information from the sensors and process the information and then give the instruction to the actuators to do work. And in order to make this possible, we need to have a network of communication, because we need to communicate between various elements in the system. So, we need to have a network, and of course, we need to have a software in order to link them together and then have a unified way of functioning. So, these 5 elements are known as the pentagon of automation, and robotics also basically depend on all these 5 elements. So, if you look at a robot, you can see all these elements are present in the robot also. And the scientific discipline which actually provides you knowledge about all these elements is basically we call it as the mechatronics, where we have the mechanics, the design and manufacturing, informatics, microcontrollers, electronics and electromechanics. So, the mechatronics stream really covers all these areas, and a student who actually has got some understanding of mechatronics will be able to contribute well to the robotics field. Does not mean that you need to be an expert in mechatronics, but the point is that if you want to be a good robotic engineer or a robotic researcher, you need to have an understanding of these elements. You cannot be in isolation, okay, I know only software, so I don't want to be only a programmer for a robot. That actually not going to help you as a designer or a researcher, because you need to know what is happening inside the robot, how is it functioning, and to understand that you need to have some understanding of these technology areas. And the challenge is basically how do we actually make sure that the students can actually learn all this field. There is no straightforward answer to that question, but one thing is that we start with some basics of these fields, and then you build upon that and then try to ensure that you are able to understand what is happening in the other field. So, you cannot remain as a mechanical engineer or an electrical engineer or a computer scientist and still want to be a robotics engineer. You need to come out of your own domain and then make sure that you understand these areas also to some extent, so that you can contribute well to the field of robotics. Now, So that is basically to tell you that an understanding of various discipline or an interdisciplinary knowledge is essential for the robotic engineer. So let us go to the robotics field again and then have a very quick look at the various classifications of robots. I showed you few videos in the beginning just to tell you that okay, these are the various robotics application, but let us have a little bit more close look at this classification. So we can say that is the main classification is industrial robots, and then one is the field and service robots, and then we can say in the entertainment educational robots. So this is a small area which actually does not have too much of interest for us, but these are the two areas where actually you can focus your attention. And under the field and service robots, you have a large variety of applications like wheeled robots, walking robots, humanoids, climbing, crawling, aerial robots, medical robots, agricultural robots, etc. Let us quickly go through these applications, the classification. So the industrial robots, as I mentioned, they are the kind of robots used in the industry, especially in the manufacturing industry, for operations like pick and place, welding, assembly, painting, etc., etc. And there are various categories within the robots, industrial robot, which we will see later when we go for the details of kinematics and other aspects. So you can see these are typical industrial robots. So up to this, and then you will be attaching a end effector at the tip, and then it becomes a fully functional robot. And there are different classification also within this. So this is known as a SCARA robot, and these are articulated robot arms, and this is the Canadarm, which is there in the space station. So space station, International Space Station has got a manipulator arm for doing repair work and pick and place operations. So that is known as Canadarm. Again, it is a kind of an industrial robot configuration. And these are some of the assembly applications: pick and place, assembly, welding, painting, machining, etc. So I showed you this video that two robots working together in order to do some machine tending and then helping for pick and place and other operations. And this is actually a welding robot. This is an assembly robot which are widely used in industries for various applications, basically to automate the process in the industry. And what are the major features of industrial robots? Again, this we will be discussing it later also. So mostly these are 6-axis robots and connected like a serial chain, like a human arm. We have joints, then we have links, and then we have joint, then link, then joint, like that. So that is basically the serial way of assembly of robots, assembly of the links and joints. And most of them are electrically actuated nowadays, but there are hydraulic robots also. When you need to have large load carrying capacity, then we go for hydraulic actuation. And having a robot alone is not sufficient. We need to have something called a robotic work cell, because a robot has to do some work. It has to have some kind of peripheral equipment in order to make sure that the robot is able to do its task. So basically manipulator is the main robot part, and then you have this end effectors, then conveyors, sensors, etc., vision, force. So all those things actually become part of the robotic work cell. And most of the robots are programmed through special robotic programming languages. So most of the manufacturers provide a programming language, so you can actually use that language and program the robot to do different tasks. And one of the advantages is that once you set up the robot, then it runs without any major deviation. So it may take some time for you to set up everything and then make sure that it do its job perfectly, but once it is set up, then you can actually leave it to the robot, and the robot will work continuously 24 hours 7 days a week without major variations or major deviation from its performance characteristics. Of course, the mechanical damages and wear and tear will cause some deviation, but you need to, as long as you take care of those aspects, then the robot will be able to work continuously without major deviation as well as major interventions. So, the wear and tear and then other mechanical damages warrants the calibration of robot. So, maybe once in a year or so you need to calibrate the robot and then make sure that your program and the parameters what you obtain from the mechanical parameters what you used in the programming, they are all correct or there is no variation. So, that can actually be done using the calibration of robots. And we can do online or offline programming. Again, online programming you can actually program the robot as the robot and the robot is doing its work, or you can do an offline programming using some offline tools and then port the program to the robot at a later stage and start working. So, important aspect for us engineers, what we are interested in is in the kinematics, dynamics and control. So, these are the three important aspect of robots. As a designer we will be interested. Of course, as a user you do not really worry about this, but as a designer, as an engineer, you need to know about the kinematics, dynamics and control of these robots, and that will be the focus of the course. Of course, the dynamics and control will not be dealt detailed in this particular course, but of course there will be you will be having additional courses available which talks about dynamics and control. So, here we will talk more about the kinematics of the industrial robots. Coming to the field and service robots, as I told you, there are different kinds of field and service robots. So, wheeled mobile robots are the one which actually very popular, and it actually the research started very long ago and a lot of development took place in this field, and it is defined as a robot capable of locomotion on a surface solely through the wheel assemblies mounted on it and in contact with a surface. So, that is known as the wheeled mobile robots. So, you can have various configurations, you can have 2-wheeled robots, you can have 3-wheeled, 6-wheeled, you can have robots for different terrains. So, lot of development has taken place in the field of mobile robots or wheeled robots. So, this is actually a robot for space application, and an extension of that mobile robot wheeled robot is now the autonomous cars, which actually is an extension of wheeled mobile robot. Now, we are actually using this technologies what we developed for mobile robots and then porting it to a real automobile and then see whether we can actually get autonomous operation of these cars. So, important issues in the wheeled mobile robots are the design of the wheels and the wheel geometry and configuration, and an important aspect is the stability of wheeled robots. So, you cannot have always the stability assured, and then we need to make sure that the robot is stable under various operating conditions, and the maneuverability and controllability are the two aspects. When it comes to the design, we need to ensure that it has got good maneuverability and good controllability also. And this actually shows the various ways in which actually we can have different types of wheels. The standard wheel and or a caster wheel based robot design can be done. Quickly go through the other fields also. Underwater robots, the robots which are being used for underwater applications. So, these are some of the commercially available robots, and this is a student robot which is used for underwater autonomous robots. So, there are two categories, one we call it as remotely operated robots and an autonomous underwater vehicle. So, remotely operated vehicle and autonomous underwater vehicle. A remotely operated vehicle is operated in a remote location with a cable is connected to the robot and to the operator, and the operator sits at a different remote location and controls it. AUV is fully autonomous, you do not need to have any pilot or a controller sitting and controlling it. So, it is a mobile robotic device designed and developed to work in underwater environments to accomplish specific tasks which are normally performed by human operators are known as underwater robots. So, as I mentioned, the two categories are remotely operated vehicle. So, remotely operated vehicle will be having a tether, a cable which will be connected to the operator, and then these thrusters will be used to propel it and using the cameras and other information, other sensors, the information will be relayed to the operator and operator can control the robots. So, these are some of the commercially available remotely operated vehicle. So, ROV technology has come to a stage where there are a lot of commercial applications and there are a lot of commercial robot available in the market, and people are using it for many applications like inspection of underwater structures, pipelines, cables, etc., etc. So, autonomous vehicle is an extension of remotely operated vehicle. So, instead of having it controlled from a remote location, you program everything in the robot itself and then make sure that the robot goes from one location to another location and carry out all the tasks and come back without any human intervention. So, that is basically the autonomous underwater vehicle. So, it needs to be programmed and it requires a foolproof navigation, control and guidance system on board to meet the mission accuracy requirements. Okay, let me skip this. So, this is a video of a autonomous underwater robots. This was actually developed for Indian Navy and we were actually part of the development of these robots. The control, navigation and guidance algorithms were developed by us. So, this shows the sea trial of these robots carried out in the Bay of Bengal. So, once it is released from the ship, you can switch on the system and it starts moving and it goes to the depth, intended depth, and then carry out its task and then comes out. Now, you can see it is being released from the ship, and once it is given the command to go, or based on the program it decides what time it has to start, and you can see the thrusters getting activated and it starts going inside the water, and of course after some time you do not see it and it will comes up after some time and then you collect it from when it surfaces, or you can actually program it to come back to whichever location you want. So, that is basically the autonomous underwater robots. Okay, let me skip this. So, another important area is robotics for healthcare. So, healthcare area is getting lot of technologies from the robotics field, and a lot of robots are being developed for healthcare applications. So, many times people think that okay, why do you need a robot in the hospital, or if when you see that a robot is going to replace the doctor and then we will be under the control of robots. So, it is not that case. The case is that we are actually using robot as a tool to help the surgeon or the healthcare provider to help him in the day to day activities or specialized activities of activities like surgery or rehabilitation. So, in a typical surgical robot, what actually happens is that in the normal laparoscopic surgery, surgeon holds the tool and then he interacts with the tissue. In the case of a robotic surgery, what happens, surgeon uses a robot, master robot, and the master robot is connected to a slave robot, and the slave robot is holding the tool and then doing the procedure. So, the surgeon is not directly connected to the tissue, but he is connecting through something called a master slave robot. So, the master slave robotic system or a tele robotic system is used in the robotic surgery, and that actually helps the surgeon to improve the accuracy of the procedure as well as to reduce the fatigue and other related effects. So, this shows a typical surgical robotic system where you have the surgeon console, where the surgeon is sitting at this location and he has the master manipulator, and he creates the using the master manipulator, he decides what kind of motions he has to make. If he has to do a cutting or he has to do a suturing, he can actually imitate that motion here using the master, and the master is connected through a controller to the slave robot. So, the slave robot is holding the tool, and whenever the master is when the surgeon is making a motion, the slave also is making the same kind of motion at the patient and do the motion there. That is how we get the tele robotic process done, and the surgeon is able to see the sight through camera and visual feedback system, and you can actually also have a force feedback. So, depending on the forces acting at this point, the surgeon will be able to get the force feedback at this end and he will be able to get it done. So, both visual feedback and the haptic feedback help the surgeon to carry out the surgery in a very effective way. So, this shows a typical, I mean this is the Da Vinci robotic surgical system, one of the only surgical robot available in the world currently. And another application of is in the rehabilitation area. So, I will quickly go through the application. So, there are two types of rehabilitation. One is known as upper extremity, that is the upper part of the body, and the lower extremity robots for the lower extremity, lower part of the body. For if you want to have a rehabilitation exercise or rehabilitation for a person who has got problem with his upper body or lower body, we can use robotic technology to do for rehabilitation or for getting some treatment. So, these are some of the rehabilitation robotic devices available in the market and currently under development. So, there are a lot of ways in which we can use the robotic technology to help the people who require rehabilitation. So, a neuro rehabilitation or any other rehabilitation requirement can be done with the help of robots. This is an exoskeleton which can be used for helping the people to walk when they do not have the capability to walk because of some physical issues. And the other one there is the bionic arm. So, you can see somebody who has lost his upper body parts. We can use mechanical devices can be attached, a robotic device can be attached to the body, and then we can use the signals from the body to activate these devices. Of course, I am just giving you a glimpse of what is existing, and of course, you will be able to get more details either through courses, additional courses, or from internet you will be able to get information. This video I already showed you that how this device can be used to help the person to carry out normal activities with the help of a robotic device. Okay, finally, the last one is the aerial robotics. Aerial robotics basically a robotic device which can actually it's an autonomous, mostly autonomous, which can actually carry out tasks without a human intervention. So, you can actually have different kind of aerial unmanned aerial vehicles. So, you can have it like a winged one, so with fixed wings, or you can actually have it a vertical kind of lighter than air and heavier than air system. So, in the lighter than air you have this airship, blimps and hot air balloons, and then the heavier than air you have this fixed wing, flapping wing and rotorcraft. So, these are the one which are not really we call it as robots, but if you properly instrument it, we can make it as a robotic device also, because since they are lighter than air they can actually go up in the air, and then what we need is the control of its motion. But in the heavier than air you have this fixed wing, flapping wing and rotorcraft. Fixed wing is like our normal aircraft. When you convert that into an autonomous thing, then it becomes a unmanned vehicle. Flapping wing like birds and other insects you can have, and rotorcraft is the vertical takeoff and landing type of vehicles. And there are a lot of domestic robots are also coming up. So, like Roomba was introduced as a vacuum cleaning robot, and then you have these wheelchairs to assist people. So, these are known as the domestic robots, and people are working on this to make it more and more user friendly. Currently they are not so friendly with the people and not so useful. So, the question is how do we make it more and more user friendly. Before I conclude, I would like to give a small reading assignment to you. So, I want you to go through this paper, the evolution of robotic research. I showed you a picture from this paper in one of the slides. I want you to go through this paper and then prepare a short report on the evolution of robotic research and what you understood, and probably your own estimate or your own understanding of what will be the future of robotics based on this evolution that is happening. So, just before conclusion, I will like to talk about the few things what is basically the hardware and software components of robots. So, we have this hardware part as the mechanical subsystem, where we have the arm, gripper, body and wheels, and then we have the electrical system which we call the motors and computers and sensor systems also. So, this part is the hardware part of any robotic system, whether it is an industrial robot or a field or service robot, you will be having this as the hardware in the robot. So, without this hardware you cannot really have a robot, and then of course you need to have the software to make sure that the robot works well. So, you have this modeling system, software, you have the planning and the perception, then control, simulation, and an understanding of these two is very essential for any robotic engineer. So, what are the hardwares to be used and then what are the softwares to be used need to be understood very well, and that actually leads to many topics in robotics. So, the topics as listed here, kinematics is one of the first and foremost thing what we need to understand. It deals with the spatial locations and velocities of a robot and effectors and its internal joints. So, we have this forward and inverse kinematics, which is most important whether you are a computer scientist or a civil engineer or a chemical engineer, and if you want to be in the robotics field you need to know the kinematics of robots. Then comes the statics, which actually analyzes the forces and the static condition. Dynamics talk about how do we actually actuate the robot, what kind of forces are needed or forces or thrust are needed in order to make the robot move. And in connection with that you have many things like trajectory control, that how do you actually make sure that the robot moves in the desired fashion, that includes the path planning also. And if it is to happen we need to have a lot of sensors, and then the sensors need to collect the data and then create a perception of the environment, that is sensing and perception. And then we have the task planning to create a task for a robot and to execute the task, and that includes the modeling of the world or the environment, and then you have the programming and simulation also. So, these are the major topics that need to be covered in the robotics, or robotics an engineer need to have a clear understanding of these topics to a great extent, and therefore we start with the kinematics in this course. Of course, kinematics and to some extent we will consider the statics also. We will not be able to go deep into any other areas in this course, but the courses which are available later will be able to covering many of these topics also. So, in the next class onwards we will start the kinematics of manipulators, which basically talks about the spatial locations and position and velocity relationships of a robot with respect to a base frame. And that is though we will be discussing about kinematics of industrial robots, the kinematics of mobile robots and other robots also can be understood once you have the basic knowledge about the kinematics of industrial robots. So, from the next class onwards we will start the topic kinematics. Okay, so let me stop here. We will meet in the next class. Thank you very much.